All right, let's just get the chat up and running. I need to change that to back to automatic. Oh no, remote. Oh yeah, here we go. So I need to actually get you back up and running on this Discord. Discord. Okay, yeah, Discord needs to not be minimized. And then you're there. Okay, yeah, that works. Desktop audio. And we're here. I need to make this a bit bigger still. Hide members. Ah, that's better. There we go. Then they are full screen. Excellent. That's sick. Alright, live streaming. That's now up and running. Oh, monetization off. What? Oh, monetization on. That's fine. That's fine. That's
what I had though when I come on the video though, bro.
Alright, so yeah, we got remote. That's fine. Let's change that. Let's go side chat. What's going on, my guys? Yo, another Tuesday in the workshop. Just focus my camera. Yeah. Wagwan Frank, Wagwan Masman, Gidrius, how's it going? 4-stroke, how's it going? Sound Doctor, bro, the Doctor is here. In case anyone needs some MOSFETs changed, we got the Doctor here. Crash, Joseph Hammond, how's it going, my friend? Nico, how's it going? Can't afford a jail from Vegas, what's up, my bro? Mark, what's going on? What's going on? How's it going, everyone? Well, happy Tuesday. Welcome to my Tuesday stream. What time is it now? More 10? Clock is 22:37. Nah. Like, I don't think this is going to be like a 4-hour stream, so you're good. What is up, 13? What's up, Amir? What's up, Leroy? What's up, guys? How's it going? Great to see you all here. Love to see it. How's everyone been? So, let's just wait for this to kickstart a little bit, to get rolling. And then we'll tell you about what today's stream is going to be. And while we do that, just while the stream is starting up and getting going, I'm just going to go ahead and plug in the good old Dayton DATS V3. Thank you very much, Mr. Sinewave02, for the swap on the V2. That was very kind of you.
No, man, it's better off in your hands than mine. I'm not gonna lie.
Yeah, focus again. That's better. She! A 20 already. 13 BTR. My man, 20 already. We haven't done anything yet, man. Why not? Why the hell not? Cheers to you, my friend. I'll hold up my hot chocolate to you, my friend. You're always dropping out the hella donations. I massively appreciate you, my friend. Thank you very much for that. It's great. Whenever I see your name pop up, I know it's going to be a good stream. Thank you very much, man. I appreciate your donation. That's crazy. Big things.
Big up, man.
You know what that's going to cover, right? Everyone's been telling me to get a Hacko FR301, right? And this thing makes me so angry, okay? Because the Hacko FR301 costs about 150 to 175 pounds for the 110 volt version, which you can use in America, in Europe, all over the world, in Asia. You want a Hacko FR301? 150 pounds. Easy, done. There's your Hacko 301. If you want a Hacko FR301 in the United Kingdom or any other country that uses 220 to 240 volts, you're looking to pay 450. I'm not even talking about double the price. I'm talking about at least 3 times the, like, 3 times the price. 3 times the price for the same freaking product at a different voltage. So I have not bought one yet because I will not pay that much money for the UK version. It is just barbaric. Is just some next thing. So what I'm going to do is buy the 110 volt version and a step down transformer, a 240 to 100 whatever it is, 110 volt transformer, which you can buy on Facebook Marketplace used for about £25. And fuck's sake. Another 20, bro. Oh, here's a pint for Sinewave02. Oh, let me shoot that over. Man, that's very kind of you. 20.
Big up, bro. Appreciate it.
No, we're going to shoot that over still. We're going to shoot that over right now. Thanks very much for your generosity there, my friend. But what I was going to say was that's going to cover my step down transformer for my Hacko FR301. So thank you very much for that. That's sick. Let me just quickly do a cheeky transaction. Payments, transfers, send money. I think I've got you saved.
Yeah, you do. You do.
Yeah, I do. Here we go. Donation. Make payment. There we go. I can show this on stream, can't I? It just says your full name. Do you mind your full? Do you want your full name being on the stream?
Yeah, that's fine.
Yeah?
Yeah,
Oh, okay,
that's
yeah.
fine.
Yeah. There we go. Thank you very much, 13 BTRX3.
Thank you, bro.
That's been sent
Very
over.
nice of
That's
you.
been sent over to Donnell. That's very kind of you. That's crazy. What was I saying? Yeah. So yeah, I was saying that I was cross about the FR301. But before that, I'm whacking out the trusty old Dayton Dats V3 because somebody gifted me very kindly the other day a Sony X-Blood. Now, my Sony X-Blood videos on YouTube popped off years ago. And I feel like they're one of the reasons why the X-Bloods kind of gained a little bit in popularity because they got some hate. You know, the X-Bloods weren't very well, they didn't have a good reputation. But since I made a few videos with X-Bloods, people started to try them and started to realise, hey, actually these things can take some power, these things are right. So I've actually got with me right here one of the X-Bloods that I was kind of keen to try for a while. It's not the exact same as the ones that I had before. This is it's a black cone, but it has the kind of vortex on the cone here, the kind of cyclone shape, and it has a 1300 watts on here rather than the 1200 watt peak. So this should be, I think this was an ever so slightly better version. Saying that, I did just give it a quick test on about 300 watts, and the coil is stankin'. It has got that coil smell. So, you know, this is pretty brand new though. It's been barely used, so it could just be that typical glue burning off the coil nonsense, which doesn't really exist. But it could just be a bit of that, you know. That's what we're saying. But what I'm going to do is I'm going to whack it on the Dayton Dats V3. I want to see what its TS parameters are like. And then I'm going to break it in a little bit using this absolutely old school. This is an ancient old school Class D amp. This is like one of the very first Class D designs to come onto the car audio market. This is a Fusion Jonah Loma. I don't know. Some old ass Fusion amplifier that used to cost £1,000 back when it was released. And it came in like a massive metal case with like wooden and everything. It was crazy, like really expensive high-end amplifier. These days, this has been battered and abused, looks like crap, and I barely get £40 for it. But nonetheless, it does bench 1,700 watts RMS into 1 ohm, which for the time, like the late 90s, that was massive amounts of power. You don't even understand. People were coming from, everything was Class AB. Everything was Class AB. The most you could get was like, I don't know, if you were getting a 500 watt amp, that was a big boy. That was a big freaking Class AB, 500 watts. And then you got these things drop.
Big up the donations in the chat, bro.
Huh? Where did that sound just come from?
Me, bro. I said big up the donations in the chat.
Hang on a minute. There's a voice coming from somewhere, but it's not coming from my headphones. Speak again.
Yo, yo, yo.
Speak again.
Yo, yo, yo.
There's some voodoo shit going on here. Oh, we got donations in the chat. Holy crap. We got a 5 from Jaguar Gamer. Thank you very much, my friend. That's very kind of you for a 5 run. I can't remember Romania?
Hey, Sam, I might be coming through the DATs for the sub.
Oh my god, yeah, you are. You're coming through the Dayton. I was like, where's this voice coming from? It sounds like he's in my room with me. But of course, I just plugged in the DATs. So Windows has changed over to that, which is not ideal. So I need to go, I need to change that back to... right, hang on, I need to go in Discord and change that. Why would it do that? Here we go.
It just defaults it, innit, when you plug it in.
Right, there we go. You're back. Right. Yeah, I hate the way that Discord does that. Discord switches over to the last audio device you plugged in. Yeah. Anyway, like I was saying, thank you very much for the donation there, my friend. 5 run, very, very cool. And also, Swirl 20 Hertz with a 5 run as well. I really appreciate you guys for dropping some love and dropping some coins on here.
Big
I
up.
appreciate that. Big up, my friend. Thank you very much. That's really kind of you. The Jonah Laumu. I had 3 of them in my Fusion BMW in 2003. Damn, that was bull. They were not cheap amps. Like, how much did you pay for them? Because they were brand new. But anyway, like I was saying, these things. Yo, Mr. Crash with a 200 Czech Republic krona. Is that maybe? Yo, just for beers and gear this time. Let the. I appreciate your donation there, my friend. That is wicked. That is a reasonable amount of money to throw someone on the internet. Thank you very much for your donation. Massively appreciate it. Very kind of you. I hope that this brings you some entertainment and some laughs this evening, this random Tuesday afternoon / evening, whatever time it is where you're. It's me.
Oh, I just deeped. You made it.
G Power.
You made it to the live.
What's going on, bro? But yeah, these amps, like I was saying, back in the 90s, when this came out, 1,700 watts, this benches into 1 ohm, was kind of like, wow, wow, that's crazy. Especially in this size, it's tiny compared to what else was available at even half the power that this was benching. So, pretty cool. I've just got it plugged in here to stress this a little bit, but we're going to bring up the dates and dats real quick because I'm just really curious to see what the TS parameters of this are, because I feel like this has been barely run in. So I feel like this is relatively close to possibly being new. I don't really know though for sure. The tinsel leads do look like they've been a bit stressed in its life. The guy said he barely used it, but I don't know. Let's just put the screen capture on here. Let's just run some free air parameters. Apologies if that came through loud as heck on your on the stream. The labels, the stickers always come off the back here, don't they? Apparently the frequency response of this is 2000 hertz. That's some next nonsense, that is. Right, let's just do another frequency because they've got a bit of a bump there. That could just be because I'm holding it a bit funny. I was just kind of curious where the FS was. Okay, no, that is still exactly the same. So the FS, we're currently sitting at 28 hertz. Wow, okay, that's pretty low still. 28 hertz FS. The QTS 0.6. All right, so it's actually not bad. It's like a relatively okay all-rounder. Should do okay in a seal box, but also would push a port load fairly well. A QMS 5.3. So yeah, it's pretty well-rounded speaker, to be fair. It's not leaning too far in one way or the other. 4 ohm single coil. I'm not going to bother doing the added mass. That's just kind of long. I just kind of wanted to see roughly where this was chilling in its current state. Now I'm just going to plug it into this old Fusion amp and just let it read for a bit and just see if any of the parameters change and just see how it moves. But everyone say hi to Sinewave02, Mr. Donnell Perry.
Yo. How's everyone
live?
doing, man?
We're live again, and he is up in here with his cheeky workbench right here. And as you can see, we have some test equipment, and we have we have an amplifier there. Now that looks like a Powerus. Oh, another donation as well from Jagural. Am I saying that right? Jaguarul. I'd run a 10 run, man. Thank you very much. Appreciate you, man. Big love. That's really, really kind of you. 10 run is 169. That's really kind. That's sick. That get you a few drinks. Appreciate it. Why is there suddenly earwax on my shoulders? Don't understand that joke. But David's always cracking out like this, the barbaric dad jokes, the kind of strange ass, you know it is. Whenever there's an opportunity for a pun or something funny, David's smashing in there with the puns. I really dislike drivers with a QTS over 0.6 since you can't get them linear in a ported box. Yeah, I agree. Yeah, above 0.6, you just start getting into like it just wants to ring at FS like crazy, and trying to rein that in to something like listenably flat or anything is not necessarily that easy. Oh, Matt, how's it going? Matt's one of the very first viewers from my very first live streams back in the day. Sign Wage. He's just called you Sign Wage by mistake. You see that in the live.
Sign Wage.
That's when you go on PAYE.
Yeah, trust me.
Not gonna lie, your amp repair's got me inspired to try and fix amps too. That's the whole point. I'm so happy that you say that, because that's the whole point. The reason I do these streams and I do all the videos It's I just want to get people into fixing their stuff. It's just like it's a great skill to have, and it's satisfying as hell. So I'm really glad that you say that. What is a good box for a 6.5-inch Toro subwoofer? Depends how low you need to tune it or what you're trying to play. Like Toro subwoofer, I don't know those off the top of my head. I don't know what the TS parameters are, but like for 6.5, trying to ask it to play super low is not going to end well in a ported box, just because they're so small. You end up getting this kind of catch-22 situation with box volume versus port length versus port area. To get it tuned really, really low is kind of difficult. It can be done, but there are massive trade-offs when it comes to that. To get a 6.5-inch tuned like 28 hertz or something, your best bet is to use a passive radiator for sure. Definitely like a 10-inch long throw passive radiator would be great. But if you're listening to like commercial music and you're not really too interested in dropping really below 35 hertz, you can tune to like 35. That would be pretty nice. That would sound great and impactful and punchy on like 90% of music that you'd be playing. Motor looks smaller. That Explode is a lower model than your old red ones. See, no, I think this one is a higher model. So as far as my understanding goes, the Explodes with the kind of pentagon cone, the smooth cone, they say 1200 watts peak on the front. Those are the ones that I had. And then as far as I'm aware, there was a next level up from those, which had a vortex kind of shape embossed on the cone, and it said 1300 watt peak, which is what one of these is. That's what this is. So I believe I've got the step up from the ones I used to have. So yeah, let's plug this into this old ass Fusion. Just get it kind of moving a bit first, while we wait for the live stream to pick up a bit. And then a little bit later on, when the live stream's picked up, and we've had a bit of banter back and forth, and we're doing some live chats. I don't actually have anything like pressing right now in the workshop that I brought into the workshop to repair. I can go and get something. I've always got tons of work to do, but I haven't brought anything up here to repair specifically. But I do have bits on my rack here. Actually, maybe I can just change to my the hat cam that's just pointing at my racks here. So these are my racks. As you can see, we have a couple of Camco vortexes, which I actually figured out, and I know how to fix these really well now. So one of them is finished. One of them is actually both finished. Just need to screw them together. I've got that old teak. Who remembers that teak amplifier from a couple of streams ago? That's fixed as well. I fitted new relays to that and it fixed it instantly, so that's great. I've got my old Crown Macrotechs. They're fine. Nothing wrong with those. Got a QSC. I've got a QSC on the far end. That's absolutely buggered. The switch from my power supply is very dead. And then up here, just got some few bits. Got a Powerus PW15K with bad transformer. And then I thought we could have a look at Audio Control. Audio Control have released a new amplifier, the A1500.1. I thought it'd be cool to kind of look at that on stream and go over the board and see what it is they've done. Have a look at the circuit. Is it well optimized? Kind of what the layout's like and stuff like that. So yeah, a few bits up on the racks. And I also have an Audison something 500.2 that's a bit buggered that I could look at on stream as well if we get that far. Oh, what 3D printer? Yeah, so I've got it's just an old Ender 5 Plus, I think it is. Yeah, it's the big build volume one I was using for Boom or Bust. Does well, to be fair. It's pretty reliable. Like, does really nice prints. Doesn't like shift layers or anything. Yeah. Doesn't really lift the bed. Yeah. What one have you got, Donnell?
It was the Ender S1 Pro.
Okay, yeah, Ender's pretty cool. I think, what's the 3D printer that everyone is like banging on about these days? Is it Bamboo Labs? Is that the one that everyone
like... A1's. I think it's A1. Bamboo Lab A1.
Yeah.
Yeah, I think it's A1.
I'm just looking at the motor of this. I'm trying to figure out if that's smaller than the one that I used to have. I don't think it is. I think it's about the same size. I feel like the motor's probably the same size. I think the difference may be in the coil, perhaps. But that frequency response is jokes. 18 hertz to 2000 hertz. You seeing this? Yeah, that's right. Rated power 380 watts. I think the ones I used to have were maybe 300 watts. It's a 12. Bamboo Labs are dead in the water with their terms and agreement stance. Oh, I did see some drama about that. I can't remember what the drama was now. Something about Was it something about their software or like third-party stuff was going to stop working with it or something like that? I remember watching some video about some drama about that. So what's the go-to now? I swear the magnet is smaller, but I could be wrong. Yeah, I don't know. I don't know if it is. I think, like, from my perspective, sitting here, it looks the same.
How many ounces do you think it is?
How many what?
How many ounces?
Oh, man, I have no idea. I don't know. I don't even know what an ounce is. Bring me the kilograms, bro. I don't know.
The ferrite in it.
No idea. Not a clue. Not got a clue.
Fair enough, bro. I'm trying to get my my quick disconnect set up.
Oh yeah, still. All right, let's just shove some excursion on this just for fun and see whether it's like got any mechanical noise or anything like that. Someone donated this to me. A good friend of mine donated this, just like let me have it to play with, so that was very kind. I'm actually just going to turn up so that it looks cool on camera. I'm going to turn up my my shutter speed. Turn up the shutter speed to something that looks good. There we go. 1, 2, 3, 4. We go to like there maybe, and then turn the ISO up to compensate. And then, yep, that's good. And then, oh yeah, open up. Oh yeah, open up. Oh no, what's going on here? Alright, alright. Open that up. So this is a DSLR. This is an old Canon 60D. So I'm just messing around with the ISO and all that. Right, so that should be good. Yeah. So now we've got a faster shutter speed. So the cone should look pretty cool on camera now, hopefully. So yeah, let's power this bad boy up and play some test tones. See what it's saying. Turn that level down a little bit. So the FS was 28 Hertz. So if I play 28 Hertz, it should barely draw any current from the power supply doing that. There we go. Oh yeah, it kind of looks a bit warpy, doesn't it? Oh yeah. They're going to protect? Oh yeah, my power supply went into protect. Okay, yeah, because the voltage dropped. Okay, that's fine.
That looks crazy.
Yeah, they don't have the most mech, and you can definitely hear that like it's starting to distort the waveform at the peaks there, but it moves fairly decent. Like it's got a decent amount of cone area. I'll give it that. Let's turn the frequency up a little bit. What are you saying? Play 30. Change the frequency of the signal to 23.8 Hertz if you can. That way you definitely get the slow-mo effect. So the camera is running at 30 frames a second. So the slow-mo effect will be like 29, about here. Just a little bit less than that. There we go. That's very slow-mo. There we go. That's the slow-mo effect. I do need a little bit more shutter speed to really get that looking good though. I'm just gonna get the lights flickering in the house though. There we go, and if we go lower than that, we're gonna make it move faster, like that. See, on this camera it doesn't look very good. Looks better on that camera. How does it look on the Hacko? it looks alright on the hack cam. The hack cam is 60 frames a second, so if we play more like 60, then it should look more like slow motion. Whoa, that was 40 amps there. It doesn't like playing the higher frequencies there. Yeah. Yeah, this is the best camera for it. Yeah, that moves nicely. No mechanical noises. Have you thrown that on the DATs yet? Yeah, literally did that just now before we started up. So now we've played it a little bit free air and got it moving a bit. I'm going to throw it back on the DATs. So I just want to see if it's changed at all. It was the FS was 28 hertz before. I just want to see if it's any different. Out of curiosity, slap it on the DATs. We had a QTS of 0.6. So I'll put it back on the DATs. We're just going to see if it's any different. Let's open up DATS. DATS. What is... Oh, Data and Audio Test Software. That must be what it stands for. What else could DATS stand for? Anyone got any funny suggestions? What else can DATS stand for? Right. Cover your ears, headphone users. We're going to do a frequency sweep from 20 to 20k. 3, 2, 1... Alright, what are we saying now? QTS, yeah, still the same, 0.6. FS, still 28. So yeah, it hasn't changed. So this woofer is like pretty much broken in. Like even if it, you know, we didn't do much breaking in just then, but if it wasn't broken in, it would have changed a little bit at least. So this is well broken in, 28 hertz, 0.6 QTS. So if we drop this in a ported box, like tuned it around... You don't want it tuned exact. Well, you could tune it exactly on FS. You tuned it around like, yeah, ported box at 28 hertz. This would probably get going quite nicely, I suspect, and sounds very good for the low power that it is. So that's pretty cool. But this amp's doing work still. This is pretty cool. That was at 4 ohm, and we were like absolutely maxing that thing out. This thing's supposed to do 1700 watts. I wonder what its freewheeling output voltage is, guys. So obviously this thing was meant to bench 1700 watts into, I think it's 1 ohm. But obviously unloaded, it will look like it's trying to make a lot more than that. So this is an old ass amp. This old ass Fusion from the late 90s. This is one of the very first Class D amplifiers to ever grace the market, and it was £1,000 brand new, and it came in this big box crate thing with wood and metal. It was like a big deal. Big amp ting. So I'm just curious what this freewheel's at on the scope with its voltage. I'm just going to go ahead and clear measurements, VRMS, and we're going to do frequency and duty cycle. Screw it, why not? Let's power this up. Is this a full bridge, or is this the full bridge, or is this the half bridge? Oh, this is a full bridge. This is a full bridge. One of the very first Class D amplifiers to grace the market, and this is a full bridge. You saw it here first, right? So what are we freewheeling at with 14.6 volts worth of input? We are freewheeling very high. Okay, there's our clip point right about there. All right, brilliant. So we have 34.24 volts RMS. So we need to times that by 2 because it's a full bridge amp. So let's just have a look real quick. Rapid tables. Would 30 hertz on a 60 FPS have the same effect? No, it doesn't quite for some reason. No, it doesn't quite have the same slow motion effect now. So resistance 1 ohm, I'm pretty sure this is. And the voltage is 34.24 times 2. 68 volts. Jesus, this can't be right. This thing's trying to make 4.5k at 1 ohm. Can't be right. This must be 2 ohm stable. It can't be 1 ohm. That's my bad. Let me look up the specs of this. This was a Fusion Loma something or other. Let me Fusion Joma car amplifier. I don't know. Fusion. What is it called? Ah, here we go. Jonah with an N. Jonah.
What happened to Fusion? I don't see them about often anymore.
No, I haven't really seen a lot from them either, to be fair, in recent times. Let's have a look together. So it's one of these. Ah, this is my own listing on eBay. That's not useful. What is the model number of this? Go to images. Ah, here we go. Was it? Oh, no, that's the 4-channel mono. Mono. Maybe it was this one. No, that's the sub. I did find it recently. Ah, here we go. Is it this one? FJL 1211. FJL 1211. Let me see this. Steve Mead Forum. Is the live chat working? Say yo yo in the live chat if it's working, because right now there's nothing popping off. Oh yeah. Change it to. Oh, this is frozen. Yeah, this.
It's frozen for you, bro.
Oh, okay. Let me close that and reopen that. Live streaming, restore chat. Yeah. What's going on? The stream still works, so doesn't it?
Yeah, I'm watching your stream.
You're watching my stream. Firefox is just like not happy. Oh, what are we doing? Ah, here we go. This one. Where's the chat? Here we go. Here we go. That's the first time that's ever happened like that. I've never had that exact weird behavior before. Alright, anyway, what was we doing? Yeah, let's have a look. So we was looking at this. What is this? Here we go. Right, so this is apparently this amplifier. See, this is where I got the specs from. 1700 watts RMS into 1 ohm. But this thing is trying to make... It's got next sine wave. It must be a 2 ohm amp instead. It can't be 1 ohm. It must be 2 ohm. So monoblock. This, unfortunately, this amp has been painted, so we can't see the model numbers or anything. Fusion Jomalo. Yeah, there's no model number on it anywhere. So I've just got to go by like what we can find on the internets. But either way, I think this is a 2 ohm amplifier, not a 1 ohm amplifier, because it's making some next voltage. But either way, it's pretty stout and it's pretty awesome. Let's have a look at some live chat, because my chat froze, didn't it? Right about, where did it freeze?
It froze just go down. It froze just at the point one of the guys said he's going to bed.
Okay. Let's just have a quick read of some of this anyway. Change frequency to signal. Yeah. Move landscape. Oh, here we go. Are the Explods good budget SQ drivers? I don't know. I haven't really tested them for SQ, but they definitely have the sort of parameters and whatever to sound absolutely fine in like a sealed box on like sensible power, not trying to go over their X-Max. They'd be fine. And to be fair, there's like SQ with the subwoofer application, it's much less fussy than like your front stage. Like you know, any reasonably half decent driver you could throw into a sort of sensible size sealed box on pretty much any amplifier, to be fair, and it's gonna blend fine and sound absolutely fine on an SQ setup. Like we're talking like the lower frequencies. For like an upfront sub in like the passenger footwell, if you're asking that to play up above like, you know, 150 hertz to work like a kick bass and stuff, then you might need a slightly better driver, something that, you know, where the SQ will matter more. But for subwoofer application in the boot, not going to make a big difference. New mic, or my EQ is messed up. Sounds terrible right now. Is everything fixable? Yeah, definitely, with enough time and effort.
Let me listen to it.
Doohickey and Thingamabob software. I like that one said, and that's good. The woofer is acting as a mic. Oh, the woofer was acting as a mic. That's hilarious. When I was tapping on the sub, was it all coming through your system? That's absolutely hilarious. So you do not have it on AC on the scope? No. So on the scope we have DC coupling. So that just means that if there's any DC on this waveform, then it will shift the whole thing up or down, which is always good to know, because if the amp starts failing and starts outputting a DC offset, then we'll at least be able to see it on the scope. So yeah, you don't want it. The only time you want the scope set to AC coupling is if you're trying to look at a little waveform that's riding along a high DC potential. So if you've got, for example, good use case is when you're trying to read the low side gate drive of a Class D amplifier, then the little square wave will be riding along negative rail. So if you AC couple the scope, you get rid of the DC rail, and you can just look at, you can zoom right in on the AC drive wave. Yeah, let me see what my storage situation is looking like on the PC. I've got 3 gigabytes left on a hard drive. To be fair, this workshop PC, the hard drive is only 120 gig, so I might just need to... Oh, recycle bin is empty. Okay, I need to delete some stuff, but either way, that shouldn't be affecting the stream too bad. Fusion, although, yeah... Firefox definitely is not too happy this evening. I'll give it that. Painting the amp reduces the thermal dissipation. It does. What is going on with my camera's now frozen? You know what? I think maybe my PC isn't happy actually. Something's up. Camera freeze. Yeah, I see that. Yeah, PC's got some gremlins tonight. You know what I'm saying? But now that we've got a decent viewer account, I think we should jump on and we should do some bench testing of this Powerus over in your gaff, my friend. Over in your place.
I'm more interested to see if how much power these batteries can put out with pretty much no charge going into it.
Let me just have a look at my PC usage real quick, because it's definitely doing some weird stuff. CPU chilling up at 55, it should be right. Wi-Fi is cooking, of course, because we're streaming. Memory's not too bad. GPU's not too bad. What have I even got in here? 960. Okay, fair. We shouldn't be running into any issues in terms of like headroom performance. Right,
cool. Let me get this all powered up.
Use the docks menu on the menu bar. Where's that? Docks. YouTube Live control panel. Here we go. So yeah, let's head over to Mr. Sinewave02 and let's see what's cooking in the Sinewave02 lab.
Cool. So I don't know if you guys can hear me well. Should I transfer over to the camera mic?
You can do. Yeah.
Alright, cool. Do that now.
Do you still have that rough 306C? Yeah, I do actually, yes. Where is that? Oh, it's in the van. Yeah, I've just got it in the back of the van.
Cool, so yeah, got Powerus 10K on the bench. Obviously, I've got this 300 watt power supply, but 16 volt.
My guy.
Like,
Yo.
Yo.
Make a scene in OBS for your iPhone only, so that when you're walking us around the workshop like this, we can see that in full screen. Because right now it's in a tiny window.
I could just pick up the camera.
Nah, that's long. Use your iPhone. It's good. It's wireless and it's easy. Just go new scene, and then just select the iPhone.
It's cool, bro. I can see it perfectly on the screen. It's alright.
All right, no worries.
Yeah, so obviously I want to see how much power I can get out of these batteries because the power supply here is pretty weak. At 16 volt, only like 150 watt. So we've got Powerus here, scope, and we're going to do it at 0.5. Yeah, we'll see how much we can get out of it.
That's a 0.5 version, isn't it?
Yes.
Yeah, so
right
we've got
here.
we've got a Powerus PW10K 0.5 version. Now this amp is rated for 10,000 watts at 12.6 volts into 0.5 ohm. So the internal rail voltages and stuff will be very similar to a 5,000 watt 1 ohm amplifier, but this just has a lot more parallel components like output transistor, output MOSFET, transformers and power supply FETs to be okay and be happy making the 10K into 0.5 without any issues.
So can you guys see? Yeah, you can see the amperage on the far right. And we'll get the voltage.
The voltage, yep.
Yep, cool. You want to see?
Oh,
the
Joseph
sound
Hammond
wave
says the
voltage.
amp is rated for 1250 at 2 ohm. Yeah, the rail voltage is pushing a lot more than that still. Oh, Joseph sent me a WhatsApp. Has my live chat died again?
It's probably froze. Yeah, maybe.
Okay, so yeah, Joseph Hammond says 2 ohm stable only. Would be interesting to see if Sinewave02 could bench it at 1 ohm. Yeah, do you want to bench this old thing, this old Fusion? See what we can do at 1 ohm. I have an original chrome plate for that amp.
Send it down with the bass phase.
Oh, here we go. We've got a picture of the full specs. So this was dynamic power 2500, damping factor, which is nonsense these days. Okay, yeah, 14 volt. See, I'm seeing so much more power than that. I'm seeing like twice the. Well, obviously we haven't got a load connected, right? But freewheeling with no load connected, this thing is trying to make about 2K into the 2 ohm. So I think this was probably a bit underrated. But it'd be interesting to see what it actually benches, hey? Maybe I'll send it down with the bass face and you can bench it.
Yeah, that's what I said, bro. That'd be good to
Although
see.
actually, that might be a good opportunity for me to use my. I've got a Taramps 200 amp mains power supply smart charger thing, so I can actually bench it right now. I think that would be enough. I think that 200 amp supply would account for about 2,000 watts RMS on the output side of an amplifier, I think. So yeah, that we should be covered with this power supply to do a bench test of this up to full rated.
Right, cool. Well, I have no idea what's going to happen on this run. So, can you guys see the amperage rate on the far right?
So the camera needs to, well, the problem is you've got a mix of backlit displays which are nice and bright, and then all of the meters which are just using LCD are super dark. So try and turn your brightness up a bit maybe, or something, or your ISO, or yeah, bit more still. Yeah, keep going. It doesn't matter too much if the backlit ones are a bit blown out. It's just important that we see the ones that aren't backlit.
Yeah, that should be alright. That's just the point where the red one's starting to go a bit overblown.
Someone said, "Oh, is that amp just sitting there on clip?" Wait, where's that chat gone? Oh yeah, 13 BTI. No, I paused my scope. It's paused. If I run it, the amp's off.
Right, let me do some test runs.
So yeah, like I said, this is a Powerus PW10K, and this one has been used and abused. It failed. What failed? Output MOSFETs failed, which we replaced. I replaced, and then the rectifiers failed. Now, one interesting thing which I think is worth noting: these Brazilian brands that are offering the same amplifier at different impedance versions. So for example, this PW10K comes in a 0.5 ohm version, a 1 ohm version, and a 2 ohm version. And essentially, this is the same PCB, okay? So the PCB trace thickness is the same, the amount of rectifiers are the same, the amount of power supply FETs are the same, etc., etc. So on paper, the differences between these versions of amplifier should only be in the output section. So the power supply MOSFETs, they shouldn't see any more or less stress across any of these versions. So the 0.5 ohm version and the 2 ohm version and the 1 ohm version, the power supply side should be equally stressed among all three of those versions. The difference comes on the output section. Obviously, the 2 ohm version, there is a higher voltage across the output section and a lower current. And the 0.5 ohm version, there's a lot of current and less voltage to make the same power. But the thing is that because the PCB trace thickness is the same and the rectifiers, they don't actually change. The rectifiers are the same. So on the 0.5 ohm version, the rectifiers are heavily stressed and are passing way more current than they are on the 2 ohm version. And as we've seen, myself and Donnell and a few other people have seen, these amplifiers, the 0.5 ohm versions, the rectifiers, they get really cooked. They really get hot, and you can see the heat marks around where they're clamped to the case. And in this one, this Powerus PW10K, the rectifiers actually failed. Okay, so I think that if they're going to offer these different versions of the same amp, I understand that you can't make different PCBs and different PCB thicknesses and stuff, that's fine, but you need to at least make the changes to the rectification circuit, which currently is not being done. And so when you're looking at buying one of these amplifiers and you're trying to choose, what one shall I get? Shall I wire my subs to 2 ohms? Shall I wire them to 0.5? What's the best one to get? My advice would generally always be to get the higher impedance version, because the current across the board is less, therefore there will be less sag across the components, or across the board mainly, because it's the same across all three versions. So the current will be less for a given power on the higher impedance version. The only time that I don't recommend going for the 2 ohm versions is in the biggest ones, like maybe the 15K. The 10K I don't know quite yet, but the 15K I wouldn't get the 2 ohm version because the voltages are very high inside and a little bit scary high, and I don't think that the design has catered for that much voltage to be stable and ringing to not occur and stuff. So the 1 ohm version is always going to be like the kind of good middle of the road point. It should be pretty reliable, current's not too high, but the 2 ohm version for anything up to the 10K would definitely be the way to go in my opinion.
No, well said, bro.
So, 13 BTRs. Sorry, go on.
Let's put this back on. So guys, this is pretty much battery power. There's nothing really going back into this into this battery. So
so we've got a bank of lithium. Was it LTO? So we've got a bank of LTO lithium that's not being charged actively, so it's just running off the battery for now.
It's being charged, but it could, a max of 150-ish. Yeah, barely anything.
Yeah, barely anything.
Right, let me do a few test runs.
What impedance are you running first?
It's at 0.5 straight away.
Okay, 0.5 straight away. Damn. Yeah. Okay, yeah, cool. So it'd be nice to have another camera view. So you know you got your iPhone, you got a black square in the middle of the screen. Can we get that turned on so we can see the amp from like the top of the bench, for example?
I don't know how well that's going to show up on here.
Yeah, that's cool. Yeah. It's just in case it catches fire, it'd be nice to be able to see it.
Yeah, is that right?
Yeah, that looks good. Yeah, that's cool.
All right. It's going to start increasing the volume.
So we're playing a 40 hertz. Can you hear the buzzing from the amp? It's crazy. So that
You
did.
can hear that, yeah?
Yeah. That did. Okay, so yeah, we're just starting out. So we got 3200 watts off the bat. I'm going to increase the level until we reach clip point.
So I'm gonna do that again because I don't think my phone was turned up all the way. So I'll run that again. There you go. How many amps are we seeing? I'm not even looking at the amps.
Do you have peak hold?
No, it doesn't have peak hold.
Doesn't have peak hold. Ah, that sucks.
No.
Ah, that's peak.
Alright, I'll run it again. So I saw 420
416, yeah, something, yeah. It'd be really nice if it did have peak hold, but never mind.
Alright, I'm gonna go up 2 now. Okay, that's bugged out. Should I run that one again?
Nah, go up a little bit more.
Yeah.
It's a shame you haven't got peak hold. It's really hard to see what the current is.
I'm covering my ears. Okay, 7,000.
7,000 watts.
How many amps was that?
I don't know. I wasn't looking at the amps. I was looking at the watts and the sine wave. 960, 946 amps.
Alright.
What? 1182 amps.
Really?
Yeah, and it's only putting out 8K. That's pretty.
You see what I mean?
Isn't that pretty poor efficiency? What's the voltage at the amp? Was like 50. What did it drop to? I didn't catch what it dropped to. Has that meter
I don't
got?
know, I'm not looking.
All right, guys. Can anyone go back in the stream? What did in that last test where it pulled the 7.9? What was the voltage it dropped to? Because I can't look at all these meters at once. And we're going to calculate what the efficiency is on that run because that seems pretty poor.
Yeah, let me let this charge up as well a little bit while you're doing that.
1182 is the amperage.
$11.82.
Yeah.
Yeah, I'm kind of waiting to go a bit more than that, especially if it's putting that much already.
Yeah. So 1182, and what was the voltage at 12.75? Thank you very much, Matt M. 12.75. So the power coming, whoa! The power coming from the batteries was 15K.
And what did the voltage drop to?
12.7.
Wow.
Why is that so bad? Why is the efficiency
Do you know what I mean?
so
So
bad?
so it's pulled 1100 amps. So what's that? About 15K?
That's what I said. Yeah, I just calculated it. I just calculated it. Yeah, 15K exactly, pretty much.
I think look at the resistance. We've gone from 0.5 to 0.7.
So the resistor's getting hot.
No, I think the leads are
leads.
insufficient. The gauge.
Can you feel the wires? Are they getting hot?
Yeah, they're not hot. Do you know what I mean? Yeah, there's nothing really to it. Have I got a temp gun I can show you guys? I'll do it through here.
But surely the SMD meter can't read the ohms when there's no sine wave playing though.
It's on dyno, so it's holding the last red one.
Oh, okay.
So look, it's 28 degrees the leads.
Yeah.
Shall we go one more click?
Yeah, why not?
All right. All right, here we go.
Fire in a hole.
Okay, see what I mean? It's got that pop at the end of the sound wave again.
No, I shouldn't do is because it the thing that I made rolls it down, so it shouldn't do.
I'll run it again. Right, you ready?
Yeah.
What's going on? Here we go. Yeah, I'm not getting any more power of it now.
That was the same amount of current, 1199, I think that was on the current. I'm not hearing the amp buzz anymore. I don't know if you changed the mic. Did you change the mic?
Yes, change. Hold up.
Okay, that's better. Yeah, that's much better.
So yeah, you can see there's something going on. Yeah, the output size there is pretty warm, even for that short test.
See, this is what what's his name? A friend of mine, Mitch, had this issue as well. He couldn't get like rated power out of the 10K versions. The 8K is good. The 5K is good. I think the 15K as well. I don't know if anyone's benched that before, but the 10K, people are struggling to get rated power out of them. What's the buzzing?
So yeah,
Buzzing is like
The buzzing-
fans and stuff.
fans on the amp, the fans on the Powerus as well. Should we do dynamics now?
I don't know. Up to you. You can do.
I've got to find a dynamic tone. I can't remember. Can you get? These guys might know. There's a more an engineering one. What is the?
I can just make you
first
one.
track tone?
I can just make you a pulsing 40 hertz.
Yeah, go on, do that for me.
Maybe it's just a relabeled 8K. Yeah, maybe the 10K maybe they just didn't bolster it up enough from the 8K. That's possibly what it is. Because we're basically making 8K there. Oh yeah, so that buzzing sound when he drops a test is literally the amp vibrating. Like the current going through all the components on the board makes a buzzing sound. It's crazy. Most amps do that. The thing that you don't notice is when you're using these amplifiers in your audio build in the car, you're not right by the amp and so you can't hear that. And obviously there's lots of bass and subs and stuff going on, so you don't hear that. But yeah, the amplifiers, when they're pushing huge current like that, they do make a lot of noise.
Yeah,
They buzz, they vibrate. It's crazy.
Yeah, I think the nicest one I've heard is the Taramps when they buzz.
Yeah?
Yeah, definitely. But yeah, bro, if you make me that 40 hertz track, I will burst it on here quickly for you guys.
Alright. Let's whack open the old cheeky Audacity. Let's make ourselves a generate tone.
Things are not bad for the batteries though. Not really charging and still to get 15.
Yeah, that's pretty good. So
Yeah.
what would you say a burst is? How long? Like a quarter second, half second? Whoop, whoop, whoop. Maybe like a quarter second.
Whatever you feel. Let me not waste his battery now.
Yeah, that's pretty right. I'm gonna roll it in. I'm gonna do two cycles of fade.
My verdict is on this amp. Obviously, like you said, where they use the same boards for different own versions, I reckon there's probably some heavy drop somewhere on this board.
Yeah, definitely. Especially with the 0.5 version. There's just so much current across the board.
Because even on them short tests, this amp is toasty already.
Is that too long?
No, that should be right. But can you put like multiple there though? Like
Yeah. I'll put multiple. I'm just making a gap. How many seconds in between each pulse do you think? 2 seconds? One, two.
One second.
One second. Okay. How many do you want?
4. That'll be fine.
Okay. Alright, cool. So I'll send that to you just now.
Do you know, so sometimes the SMD meter glitches
It's
out.
40 milliseconds is the original. The dynamic tone's 40. Okay, so maybe we'll do 40 then.
Yeah, okay.
Alright,
Perfect.
cool. Just change that. Generate tone.
I think it will do rated on the burst because yeah, I think it will.
Yeah. That's like tiny. That's like how many cycles is that? That's 1.5 cycles. I don't know if that's enough. And it pops as well. Like that's terrible. Because it ends the signal halfway through a cycle, so you get this awful pop sound. See if I get rid of it. I'll tell you what we're gonna do. We're gonna do 120 milliseconds, but I'm gonna fade it. I'm gonna slightly roll in. I know that that's not necessarily dynamic or whatever. But I'm gonna maybe I won't roll. Maybe I won't fade it. Maybe I'll fade out. So let's do 80. Okay, 80 milliseconds. And then let's cut the end off here, just so that we're not ending on like a high. And then let's fade out. Let's do one cycle, 2 cycles. So let's do 2 cycles. And let's fade out on the 3rd cycle. All right.
Perfect.
There we go.
Turn that fan off now. We don't really need it.
There you go. That's so much cleaner. That's so much better.
Yeah, that's about right. I can't lie. That sounds like the one I was using before.
Alright, let me send that to you. Someone says, nah, I used the first. Well, I've overwritten it now, so it's fine. Alright. Document. Dynamic. There we go. Should be coming through to you, my friend.
Thanks, bro. Would you send it on WhatsApp?
Yeah.
Yeah, there we go.
Right, just joined and my sub started booming off and then on. Haha, good, reminds me it's working. Nice. I had one made up for Donnell ages ago, but he found the original. Matt says, what are you saying about the SMD meter? What are your thoughts?
It's good, but it can throw out some crazy numbers sometimes.
Well, it's very fast, isn't it? The refresh rate. So you didn't make any content on this, but I sent Sinewave02 my SPL Lab Next LCD, which is basically like the SPL Lab version of the TurnLab Magnum. It's basically the same refresh rate and everything. It's very, very similar. And we did some comparisons on the power readings of the SPL Lab versus the SMD meter, the AMM1. And the refresh rate of the SPL Lab was too slow on music to pick up the peaks in the wattage on, like, you know, the music on the transients and on the kick drums and stuff like that. It was so when you played music and you had both of those meters running and on peak hold, the SPL Lab would be showing like 600 watts and the AMM1 would be showing like 2K. It was wildly different.
See, but in that aspect, how I know when I tested it on the Crown, how I know that the SMD weren't overshooting it is because it's a 2100 watt rated amp, and it was showing dynamic peaks of 2400 watt.
Yeah.
So that's realistic.
Yeah, definitely. Yeah,
It's just hard with the Taramps. It's hard to believe it. Do you know what I mean?
I do trust the SMD AMM1. I do trust it. I think
Yeah.
that a lot of people think it reads high because it's reading so much faster than any other meter. Its sample rate is so much faster than any other meter. So yeah, dynamically, these amps are making these kinds of powers, and people will see the number and be like, "Nah, that can't be right. That can't be real. That can't be true." But actually, that's how much power was just dumped for that like 40 millisecond or whatever. But the AMM1 does actually pick that up, but the Term Lab and the SPL Lab just won't. It won't catch that.
Be a good test with this oscilloscope if it will pick up the bursts.
Yeah.
All right, let's get this. I'm gonna do a few practice runs, set my level. See. Let me change the mic over. Oh, look, even the amp's getting happy already. I haven't done nothing yet. All right, let's set this up. We'll go like a.
It sounds a bit. The fan sounds a bit like it's catching or something.
It's not when it spins up. It's fine.
It's like.
Yeah, tell me about it. Right, let's try this. Low volume. See what I mean? Look what it's doing. 0.1. That's not real. All right.
Yeah, it does. It does do some glitchy stuff sometimes, eh? Okay, so the scope's picking up like the first cycle.
Yeah. Right. I'm gonna start going into it now. See, look it does at the end.
So it's doing a lot more power now. It's doing 9.4K.
Yeah, I'm gonna run it again.
You're going to turn it up a little bit more, or is that
Yeah,
at clipping? Yeah, because we haven't reached clipping yet. We haven't got it to clip. Is the limiter on?
See, look what it's doing.
Yeah, 0.1 ohms. Yeah, that's not right. So the meter had a glitch then.
All right, let's run it again. It's probably gonna keep doing it now. I'm probably gonna go up again, you know.
Where's the limiter dial set to on the amp?
It's on maximum.
Oh, turn it to off. Turn it to minimum.
Oh, Sam, I'm not sure about that.
Because the thing is, I think the limiter does actually prevent the amp from getting anywhere near clip point, so it won't make great power.
All right, cool. I'll do
Maybe
it.
maybe put it down to like a third.
All right, bet. I'm gonna back off the volume there now.
Okay.
There we go. 9,388.
Yeah.
Got one more.
Up at 0.7. Is that because stuff's getting hot?
Yeah.
Yeah. Still no clipping though. Oh, there, I saw a little bit of clip there. Did you see?
Yeah.
Yeah, okay, so I saw a little bit of clip there. Yeah. So accounting for the 0.7 ohms, which it's risen to because the stuff's got a bit hot, that is the 10K that the amp's rated for. But it only seems to really be doing it dynamically.
I'm gonna go one more, just into a little bit of clip.
Okay. A little bit of clip. That's some henge clip. Yeah. Yeah, we're not really getting much more power there, are we? It's 9.3K.
No.
Yeah, no.
But yeah.
Interesting things. Interesting things.
So do you reckon if it was actually at 0.5, that would have been 10K?
Yeah.
Fair enough.
So
it's
that's
weird,
really
though,
that's
when I
really.
used the Taramps, yeah, go on, bro.
Haven't you dynoed one of these before though, and you did actually get like over 10K
On music.
on music? So it was kind of like dynamically that, wasn't it? Yeah.
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 I got 11K. I got like 11,200 on music.
Do you know what the impedance was that it was reading when you did that?
Same as this.
Was it a resistive load, or did you have it connected to a sub?
No, resistive.
Oh, resistive, yeah. Damn.
It was the same time that the inductor started shooting out smoke.
Yeah. I remember. Yeah. Maybe the inductor is the thing that's limiting this a little bit then.
Well, we know the right amount of power is entering the amp.
Yeah, definitely.
It's just not
It's
coming
not,
up.
It's not exiting it. Yeah.
Yeah, it's not coming up. Right, let me switch back to.
Nah, that's
This is why I
really
like
interesting.
the Big Boss 8K though. The Big Boss 8K, when I do that perfect all the time. Same numbers all the time.
Same numbers all the time. Yeah.
Mhm.
Yeah, Taramps definitely have cooked up a nice amp with the Big Boss and the Smart series. They're really cool things though. They are.
But yeah, I'm looking forward to retesting that bass face amp definitely.
Yes, so guys, if you were here last time we did tests like this with Donnell, you remember that we did the bass face amp, which unfortunately failed. Oh, you sent me the video. No one saw the video. Let me put it up on the stream.
Yeah, slap it on.
Donnell took a video of when the bass face 5K failed on his phone, and you can hear it much clearer. So do you remember that the MOSFET leg like snapped and like fused open? It sounded crazy. I'm just gonna try and find it in our chat. I'm just gonna scroll up a fair bit on here, see if I can find
If
it.
not,
I'm just trying to find it.
few.
When was it? When did we do it? When did we do the stream? What day was it last week?
Bro, I could not tell you, but I'll see if I can find it.
Was it like Wednesday last week? Oh, here we go. There's a picture of me showing you that I got the parts. What's this? Tune's nasty. Oh, here we go. I found it.
You got it, yeah?
Yeah, I got it. I'm just going to save as MP4. Alright, so I've saved that. So I now can enter that as a media file in here. So guys, what you're about to see is when the bass face 5K failed on Donnell's bench, but with better audio, so you can hear the sound that it made when it failed. So it just killed the output section. It didn't kill the power supply, but it made a pretty big pop sound when the MOSFET leg blew open. So let me go media source, amp pop, create new, and then browse for files, downloads. Here we go. You ready? You restart playback when source becomes active. Close file when inactive. Yep. Use hardware coding when available. Yeah, do that. Here we go. Is it playing? Yeah, I don't know if you heard that. I didn't hear anything through my speakers. Actually, I think I need to go ahead and advanced audio properties. I need to monitor that. Yeah, here we go. Amp pop, status active, monitor. Here we go. Monitor and output. There we go. So let's play it again. So just towards the end here. So this is just doing the dyno. That big click, that big tick sound, that was the output MOSFETs shorting and fusing open one of the MOSFET legs. That it was all it was. Tick, sounded like a relay almost. Now I have already got the replacement parts. I bought some nice strong output MOSFETs here. These are about as big as we could find for like sensible prices. Even actually, these were actually even better than some of the even more expensive ones. So these are some pretty beefy ass output FETs. So we're going to load these up and see how these do. I'm really curious to see how these perform, because if they do well, then I might start using them in other amps, because they weren't even that expensive, to be fair. I'm just curious what the gate capacitance is and stuff like that. Let's have a quick look. So yeah, not even too bad. A gate capacitance of 5 nanofarads, VT 3.3. The RDS you have to ignore because it doesn't read it properly. So I think these might do quite well. The power supply MOSFETs were fine. They didn't get stressed or anything. So they should be absolutely okay. And I'm going to change the output inductors for much bigger ones that come with the Sundown SFB 13K. And we're going to beef up the traces a little bit. Maybe the rectifiers as well. So I should be receiving that bass face amp back tomorrow. So there'll be another live stream tomorrow where we do those upgrades and and give it a little test here in the workshop, and then send it back to Sinewave02 for the bench testing, and that should be really fun. Beverage, could I? Yeah, could I be interested in working? Could you be interested in working on a 90s Technics preamp? I'm afraid not, my friend. I'm not really taking on that kind of work at this time. You'd have to be based in the UK as well. But if you are, then I'm not really doing that sort of stuff just now. Have you seen the Taramps DS 2000 x 4? Yes, I have. Could it be reliable? It should be. Yeah, getting 1000 watts RMS from a modern Class D circuit is not difficult. It's very easy. Loads of like modern MOSFETs and drive architectures that can do that in a very small package. So yeah, absolutely, 4 times 1000 watts RMS is very achievable these days, and it should be as reliable as a 1000 watt RMS monoblock, like, you know, in that same sort of like style. So all I would say is don't clip them, because from experience of those amplifiers, the output filter network doesn't like being clipped. You'll burn up the film caps. So just as long as it's not clipped, then you'll be fine. Yeah, nah, it's not something that I'm taking on at the moment, I'm afraid, Drakey boy. Sorry, buddy. But yeah, I'm curious what this makes though. Like the bloody oscilloscope seems to suggest that it's going to make like 4K. Now I do have a power supply here, a 200 amp power supply, so I could maybe dyno this. The only issue I'm going to have is that the power wires are not exactly going to be fitting easily in there, because this is some 70mm welding cable, and these are like some 4 gauge. I don't even think these are 4 gauge. I think these might even be 8 gauge terminals. So I'm gonna have to do some sketchy stuff, like just bend the strands out of the way or some rubbish like that to get it to go in the terminals. Yeah, we could do that. This is the positive, isn't it? Yeah, okay. So this is gonna, right guys, this is gonna look sketchy AF, because I'm just gonna literally bend these strands out of the way, okay? Because I can't be bothered to, I don't have any reducers for this size or anything like that, so we're just gonna bend these strands out of the way. And we're gonna put the Taramps power supply to the test. Now, you guys haven't seen this yet, but yeah, Taramps were very kind enough to send over a couple of these, or actually one of these. And unfortunately, I had to do some modifications to it to get it to work in the UK, which I can talk about in a bit. Because I do actually have one that's open with the back off.
Yeah, man, you see that stuff? They try to shut us down, have to make us have no power, bro.
Yeah, I know. Alright, let's work this out. This is gonna look and be so sketchy. Oh my god. Nobody clipped this.
They'll definitely clip it nicer though.
Like, literally.
Definitely. I'm just packing away. I'm here. I'm just packing away.
Yeah, that's calm. That's calm. Have you got any other amps you can bench test for fun?
It's getting. I'm not gonna lie. I don't want to be making no noises to now. Okay, it's getting late.
Oh,
It's
fair.
being exploded. It's being
Fair,
exploded.
yeah, fair play, fair play. I feel you on that. I feel you on that.
Yeah.
Look at the amount of excess not going. I'll zoom in on this in a minute, guys. Don't worry, you'll see it. Average car audio starter pack. Yeah, I know. This is the worst. Don't do what I do, guys.
I tell a lie though, bro. You see, if I get another power supply,
Yeah.
I'll do a video on this for YouTube.
All right. No.
See if I can squeeze more power out of it.
What's that for? Sorry, the Taramps or
The Powerus.
the
I
Powerus.
haven't done a YouTube video on it yet. So.
Okay. Yeah. Well, I'm glad it survived.
Yeah, that's a plus, isn't it?
Yeah. So those rectifiers that I fitted are obviously, you know, doing okay.
Beefy boys.
So just get these strands out of the way. This welding cable is some of the least flexible stuff. Oh, guys, has anyone else had it before when they're working with welding cable and the strands, they're like very sharp and they go into your skin? Have you ever, like, when you accidentally like push push your finger on the strands and it like injects into your skin. Oh, it's the worst feeling. It's so painful.
Let me tell you a story. Exactly
A
what you're just saying.
needle.
So, you know, there's a fan on my power supply.
Yeah.
Yeah. So obviously, I've taken up the welding cable,
Yeah.
and all the strands have pinged out from the power supply, and it sucked it inside of the power supply.
Oh no, which amp was that?
This was the Big Boss 8K.
Oh no way! Did you have to like open it up and get them all out?
Yeah, of course.
Yeah, yeah. Was it on at the time or was it off?
No, it went into the power supply because the fans on the power supply were. Yeah, the power supply was on.
So it's on. Oh damn, that's crazy. That's so lucky.
Yeah.
That's so lucky that nothing like exploded. Jesus.
Scary things.
Alright, this is the most sketchy wiring that you're ever gonna see on this channel because it's trying to squeeze. Now, this is actually what's it called? This is actually a controversial topic, but if your like power cable is too thick for the amp that you're putting it into, genuinely the best solution is actually just to trim the excess strands and then heat shrink it or like, you know, Tessa tape it or something, to trim off the excess strands that won't fit in and just make use of the strands that will fit in. Trying to use reducers or anything like that is just adding resistance and connection points. Using the copper that's in the wire that will fit is absolutely fine. The electricity doesn't travel down each strand individually and separately. They're not laminated, so they combine as one essentially in the wire. We're not talking about high frequency switching here, so the skin effect is not. This is DC, okay? So DC, they combine as one. So when it gets to the end of the cable, the strands that you're cutting off, you're not stopping that current from coming out. It's just going to be channeled into the slightly thinner bit with the less strands that you've created there, which is going to happen if you use a reducer anyway. But using these reducers and stuff, the contact patch, the contact area of that terminal on the amplifier's terminal is tiny compared to if you just trim the strands, put it in, and they all squish out onto the terminal and create a high contact area. So yeah, best thing to do is if you're doing a permanent install where, you know, where you're using wire that's too thick for the amp, the best solution definitely is just to trim the strands.
What's your favorite type of cable? Like, do you like it when it's tin, pure copper? Like, what are you saying?
Don't really have an opinion, to be fair. Pure copper, I guess, maybe? I don't know. Yeah, I don't really have an opinion, to be fair, either way. The tin is good because it stops it from corroding, so
Yeah.
I guess that's cool, but...
I've got all sorts, man.
So if you want to put two 70 mils into one amplifier, if you want to use dual power cables, the best solution for that, okay, is to put a lug on the end of each 70 mils. You've got two 70 mil wires. Put a lug on the end. Actually, where are they? I've got them. Oh, I've gone outside. Put a lug on the end of each 70 mil. Okay, then screw them down onto a copper bar, like a piece of copper bar, screw the lugs down, and then screw another single 70 mil cable, only like maybe 10 centimeters, 15 centimeters long, onto that copper bar that then goes bare wire into the amp. So you're essentially creating a 2-to-1, but the final termination into the amplifier terminal is a very short piece of 70 mil, and that will give you the best results, the lowest connection resistance possible. All right, so we have the Fusion amplifier hooked up to the Taramps power supply. Let me just get the Taramps power supply out of here so you can see it a little easier, because it'd be nice to showcase it a little bit, wouldn't it? But my power wires are very, very short, so let's just be a little bit careful here, because I don't want to be pulling them out of the amp or anything like that. And I think we're going to have to put it on top, maybe like that. Have to put it on top like this. See that? Yeah. Okay. So this
I
is
can't
the
lie. The power cable that comes with them is beefy as on the Taramps. I
I
can't
know
lie.
the mains cable. This is a very beefy mains cable. To be fair.
Yeah, for sure.
Yeah. Especially since we're in the UK, so we have 240 volts, and each plug is supposed to be fused with a 13 amp. Each ring main is a 30 amp breaker, and then the actual house, the entire house is fused or breakered at 100 amps. Which at 240 volts is like a decent amount of power. So yeah, it cooks. Right, so there we go. We have our power supply, mains power supply connected to our fusion amplifier here, and now we're going to have to hook up some dummy loads. So apparently this is a 2 ohm stable amplifier. So let's grab some resistive loads here. I wish I could zoom out more on this camera, but this is as zoomed out as it's going to go. So we've got two 4 ohm resistive loads here that we're going to parallel together. Okay, that's going to be Tucker Real Estate would love to send you an amp for repair. Yeah, it sucks, man. The overseas shipping is just absolutely ridiculous. Yeah. You know what I'm waiting for?
Like that on that,
Huh?
bro. What's the voltage drop on? What is the voltage drop on that? Is it bad or is it alright on that?
I don't know. I haven't done any like big stress testing with it yet at all. So this is the first time we're gonna sort of stress this power supply and see what it's all about. So this Taramps power supply is a smart charger / power supply. So it says that it can do 280 amps dynamically, 200 amps continuous. So you can use it to charge your like lithium banks and your batteries and stuff like that, or supply constant power when you're running at a show indoors. Plug this into the mains real quick. And it's a smart charger, so it supposedly can detect when it's charging batteries, and it can detect the battery charge rate and charge like how charged it is, so that it's not overcharging the battery, but it's charging it at a decent speed and stuff like that. I don't really know. I don't have any batteries really to charge. What I do have though is I do have a bank of I do have 2 banks. I have 2 banks of ultra capacitors, a Maxwell. What are they? 2.8 volts, something like that. I've got 2 banks of ultra capacitors, which I definitely should or could be using in this setup here. It would definitely take some of the transient loads off of the power supply here, but I can't be bothered to get them out just now. Why was I even saying this? Yeah, that's the only thing that I have that I could like charge. I don't have any big lithium batteries or anything in the workshops here, so.
Answer some questions. Hold on, I see the question on the.
Alright, so yeah, we have the Taramps smart charger, we have the Fusion, Jonah, Lomu, whatever it is. We have the gain turned down a little bit here. There we go. So we have a 2 ohm load connected, so we're pretty much ready to cook here. I'm going to send a 50 hertz sine wave in. We need to connect the scope up to both channels because this is a full bridge amp, so we're going to need both probes shoved in here. One in there. And one in here. Now this thing was trying to make a cheeky 4K, so let's see what it's actually going to do. I'm going to turn the power supply on now. Okay, anything? Oh yeah, got the blue light. All right, nice. Let's just ground my scope to this as well. I can't remember if this scope is actually grounded to the power supply, so I'm just going to do that real quick.
I can't lie. You lot are lucky. You're getting 2 dynos from me and Sam.
I know, right? Mad thing. 2 dynos, double dyno Tuesday.
Literally.
Okay, so now I'm just going to hit the power button on the Taramps smart supply here. So we're coming to life. It powers up in smart mode first, and then I think when it doesn't detect batteries, it then flicks over into full power, I seem to remember. So at 14.6 volts there, and now it's, yeah, see now it's flicked over into full power mode. I've got the voltage turned up to 13.9, I don't know why, it's just randomly. So let's now power up the Fusion amplifier. Turn on my scope to both things here so we can see both waveforms. Oh, helps if I turn my power supply on, doesn't it?
What amplifier is that? Because I've reused the case. What model?
I don't know. I'm not sure really, yeah. Okay,
See where
amplifiers
the
come
remote would
on.
go.
As you can see, this is a full bridge amp, so we have 2 sine waves on here. So we're going to go gently and gradually up to clipping, okay? Because, yeah, I don't really know what's going to happen with this thing. So I'm just going to go ahead and put my hand on the stop start, the source run. Okay, a little bit higher. A bit higher. Okay, was that clipping there? Was that clipping a little bit? I think it might have been. There we go. There's a little bit of clip. Right. So we need to back off there a little bit. The setup seems happy.
Yeah, the voltage ain't even dropping.
Okay, that's pretty much our clip point. As you can see, the voltage sag is hectic compared to what we were freewheeling at. So what was we freewheeling at? Like quite a lot. But the voltage is now 23.27. I'm just going to turn the power supply off here. So if we just do a little calculation, Marubi. Reset this. So we have 23, so that's 46.54. Quick maths. I think I did that right. In the voltage and in the current, in the impedance, we got 2 ohm resistive load. So the power is, oh, you know what? It didn't make rated power. Oh wait, oh no, sorry. No, yeah, hang on, what am I doing? 40, yeah, 46. Point 2 ohm. So what was I seeing when I was trying to make 4K? This is crazy. The voltage sag is like wild compared to what it was freewheeling at.
Let me go
Now,
back and see what.
the power supply here wasn't dropping. The power supply here was 13.9. Okay. I think what we're going to do is power it all back up again. I'm just going to have a look at the voltage, the DC voltage of the power supply here when it's under test. So if I turn my multimeter on real quick, where's the multimeter cam? Oh, it's like chilling down here for some reason. Here we go. Here's the multimeter cam. Let's just hook up the multimeter cam. Connect the multimeter to the amplifier power terminals just so we can see if there's any voltage drop. Because obviously we're at 13.9, so that is a little low. So this amp will be rated at, I think it was 14 volts, 14.4. So we can do square law correction factor for that real quick. So what have we got? We've got 1082. So if we want to do square law correction, then what we need to do is we need to take our, I think we do our target voltage, which is 14.4.
Hey bro, I just clocked. You can do your own dynos as well. You got your SPO labs thing, haven't you?
Yeah, but like because we've got a resistive load, we don't need to do that. We can just calculate it. But yeah, I do have my SPO lab, so I can plug that in and see the power like on the screen there, definitely. Divided by 13.9. Okay, square the result. to power 2. That's going to give us our correction factor, and then that times by, what was it, 1082.98. Okay, so yeah, accounting for correction factor, this amplifier just made 1162 watts into 2 ohms, 14.4 volts. If the voltage was on the smart charger here was a little bit higher. So yeah, it's a little shy of its rated. We could try 1.3 ohm, but given that how much this sagged, I don't know if it's gonna do much more. I tell you what, I'd be more interested to see what it does at 4 ohm. Let's see what it does at 4 ohm instead. I remember there was some amps that were rated for way more at 4 than 2. Alright, let's plug that in. Plug that back into both sides. So yeah, this thing's not actually doing as much power as I thought, which is fair enough, interesting. I thought this was, I assumed this was 1700 watts into 1 ohm, but no, it's nowhere near, it's nothing like that.
Yeah, I'm sure you can fix that though.
Maybe, I don't know. It needs a full redesign. Yeah, so let's turn this all back on. Right, 13.9 in full power mode. Excellent stuff. Let's turn the amplifier on. We're up and running. Okay, so let's find our new clip point at 4 ohm then. Oh, heavy clip. You know what, actually, it seems to have very similar clip point. Alright, there you go.
Can't lie, that charger is sick though. It's not even dropping.
That's great. Alright, 28.33. So actually, the rail voltage sag... The rail voltage sag from 4 ohm to 2 ohm actually isn't that bad. I'm tempted to try 1.33. This shows that there's a bit of headroom in the components here. The fact that from 4 ohm to 2 ohm isn't that much different. So we got 28.33 times by 2, 56.66. So 56.66 into a 2 ohm load. So, oh no, sorry, it's into a 4 ohm load, isn't it? 56.66. It's getting late here. So 802 watts. Okay, so we did lose a lot of power actually. We did lose a fair bit of power going from 4 to 2. On paper, if everything was like perfect in this amp with no rail sag, this would try to make 1600 watts into 2 ohms, but we only actually saw just over 1000 watts. So actually, yeah, that's pretty poor, isn't it? That's a big difference. That is a big difference. If it's full bridge, maybe test 1 kilohertz. I don't understand your thought process there. So tell me your thought process behind that comment, Morten. If it's full bridge, maybe test 1 kilohertz. So what does its bridge topology have anything to do with its frequency response? I am very curious to where your thought process of that comes from. Later on, David, thanks for joining. Do we try 1.3? I don't know. I feel like it hasn't got it in it.
Don't lie, Sam. You're choosing the safe route today, innit?
Yeah. Well, I just don't want to blow up this Taramps for a start. Like if the efficiency drops off like crazy and I end up drawing like 300 amps. All right, let's try it. Let's hook up one more resistor in parallel. Let's try 1.3, just to see how much we lose.
See that? Sam's a true warrior.
What did I miss? Did any amp blow up? No, we're good this evening. No blown up amps, unfortunately for you. I'm sure you probably wanted to see a blown up amp, but yeah, not today. Not today, my friend. No blown up amps here. Although we might blow this amp up now at 1.3, who knows? We'll see.
Touch your desk.
Let's shove these in. So, Donnell, based on all of the testing that you've done with amps on your bench, which amplifier for you is your favorite, just from like vibe and feel and like just, you know?
Oh, everyone knows Big Boss 8K. Everyone knows that.
Oh, you love it, Big Boss 8K. Nice, nice.
Because the current it draws to make the power, it's like 800 amps.
Yeah, very efficient, isn't it?
Yeah, and do you know what I mean? We've got Mr. Powerus here pulling. Do you know what I mean? It's a bit.
Yeah, I'm a bit shocked and surprised actually. Like the Powerus 10K, not a big fan. Based on the testing that we've done now and that I've seen other people do. The 8K is good.
It could just be the 0.5 ohm version though. To be
yeah,
fair.
it could just be. Yeah, I mean, to be fair though, I think Mitch has tested the 1 ohm version and he got the same result. So maybe it's the output inductors that's the issue, but I don't know. Although the current would be much less, wouldn't it, at 1 ohm? So I don't know. Yeah, it doesn't seem great. Yeah, what's your top 3 favorite amps to test? Can even be something small.
Top what?
Top 3 favorite amps to test and mess around with. So Big Boss 8.
Big Boss 8. What, that I have or I want to test?
Well, that you have tested, that you have experience with, ones that you really like.
It's mostly it's been.
Do you like the Big Boss 3? Do you like the Big Boss 3?
Yeah, but it's very noisy, the amp.
Oh, is it? Does it buzzing or the fans?
No, like on current clip, it's very like there's a lot of high, like how can I say it? Like high pitched screechy sounds that comes out of it.
Oh really?
Like from the actual speaker. Yeah.
Morten says late here as well. Just ignore that comment. I feel you there, my bro. When them hours start ticking by and brain starts thinking stuff and it's like, So all right, cool. Powered back on. Let's go back on with the power on the amp. We're up and running. So we're down at 1.33 now. So let's find a clip point at 1.33 and go from there. Whoa! Something hectic just happened there, bro. That did not like whatever that was. Did you see that?
Yeah, you're brave.
I swear the Class D just completely broke down. Something crazy happened there. Whoa! This amp does not like... Okay, let's just go down a little bit before that. Alright, that's as much as we're doing. Any touch more than that, and you see what happened on the screen. The Class D breaks down completely, and it just starts sending full DC rail into these loads. Jesus, it does not like that. Old Class D sucks when it comes to this stuff. So we saw only 17.29 volts there. Any more than that, and you saw what happened. Oh, that was absolutely horrendous. So 17.29, 34 fucking, I don't know, but 34, let's call it 35 volts. So 35 volts into a 1.33 was only 921 watts. So we actually went down on power because the amp was just not happy. So yeah, this amp actually has gone massively down in my books and my recommendations. This is a piece of crap, and I'm just going to flog this for 20 quid. Absolute joke. This sucks. Piece of crap.
I mean, 1,000 watt amp for 20 quid. That's a bargain still. I'm not gonna lie.
Yeah, no, yeah, it'll be a good bargain for someone, but it looks like arse. It is old as heck. Yeah, it's not the most ideal thing. But we've got a couple of things that I still want to show you guys tonight, right? This right. I need to show you this Taramps power supply. So anyone that's ever done anything with circuit design will be shocked at this. And Taramps' reasoning for it is pretty poor. Now, you guys know that I like Taramps as a brand, but I'm not brand loyal to anyone. I will rate a piece of equipment when it's good, and I will slate it when it's bad. It doesn't matter who's made it. And I think a lot of people think that I really love Taramps and I just say good things about all their stuff. That's not the case at all. I love some of the stuff that they've done. I love some of the amps that they've put out. I think they're great. I think some of the amps have some drawbacks, and I think the head unit sucks ass, but it had potential. But the implementation was really bad, so I made that video. And for these smart chargers, from what I've seen of my experience of them so far, has not been great. Just not in terms of how much power they can make or anything like that. Just the way that they've been designed prevented them being used in the UK. I had to do a modification to them. They're supposed to be rated for up to like 240 volts. They have a they self-detect the voltage, but I had to do a modification to make this actually usable in the UK. So I'll show you why. And I have one on the bench that's open that I prepared earlier that I'm just going to grab out for you. Sam, aren't you brand loyal to DD? No, not at all. I was never brand loyal to DD. I liked DD. I liked the stuff they were making. And then as soon as they stopped making stuff that I liked, that I thought was any good, I stopped rating them. I stopped recommending them. I stopped working with them. I wasn't too keen on their business practices. I wasn't too keen on the quality of assembly quality of the stuff that was coming out from the USA made stuff. I wasn't too happy with the pricing of like the amplifiers and stuff. Everything was very, very expensive, and the quality just wasn't there for what you were paying for. Like I've got DDZ415s in my van. Yeah, like they're great. They have potential, but they're just massively hindered by mechanical issues. Like the spiders are awful. The spiders are awful. Had tons of issues with the spiders. They're not durable either. They're not durable. Like so many of these like subs coming out of China are actually really well made. Like the Chinese factories really know what they're doing, and they have the infrastructure there to make stuff that can take abuse. A lot of the sort of more what you'd call mass produced subs, actually even the Redline subs take more mechanical abuse than the DD USA subs do. That is a pure fact. You can mechanically abuse the DD Redlines and they will stand up much better than the USA made stuff that just tears and like rips the surrounds, and like the spider does weird stuff where it gets a notch in it, and yeah, so I just wasn't too happy with the stuff that they were doing. And the Redlines, I do like the Redlines, but I know the Redlines are bespoke, in a sense that you can't get exactly the Redline sub from another brand, but you can get an equally or better performing sub from another brand for cheaper than what they ask for the Redlines. So it's all about, I am all about getting my fellow bassheads the maximum product for their money. And unfortunately, even though some stuff that DD make is great, I just can't recommend them based on that because it's so expensive. You could get so much better results with other brands for the same money. Have you ever tried something from Gaz Audio? We don't have it here in the UK. I think I have actually seen one. They're very generic stuff. They're nothing special. It's just like the same old stuff with the different logo slapped on the front. But again, because this brand is just buying stuff from factories, there will be some stuff that's great, there'll be some stuff that's good, and there'll be some stuff that's not so great, depending on what line of amp they bought at the time. This has 4 40 amp fuses. Kind of stank in there, not going to lie. I think it did have a blown power supply, so that would explain why. Let's put that to the side. And let me show you. Let me show you the Taramps smart charger. Right, here we go. So this is another one that I've got in pieces. This one actually failed on like the second power up. This was meant to be going to Donnell, to Sinewave02. We got 2 of these here, and one was for me, one was for Donnell. But this one unfortunately failed. But it didn't kill any of the parts that you'd think it would kill. Okay. I mean, let me show you what's going on here with this.
Bro,
You can understand.
I've never seen that them things ever make an LED light bulb dim.
Yeah. So what we have here is we have a mains switch mode power supply, essentially, that outputs anywhere between like 12 and 14 volts on the output. So we've got 240 volts coming in, and then we have 12 volts going out. So the way that this circuit works is, you have to excuse my modification, ignore that that's all here for a minute. We have AC mains coming in. The AC mains gets rectified by this full bridge rectifier, and we have the rectified DC of about 350 volts stored in these capacitors. Okay. Now let me just let you think about that for a minute. Okay. So we have empty capacitors, completely empty, 0 charge in them, and you plug this in to your mains. Okay, with AC 240 volts on it. And the first thing that the AC waveform sees is instantaneously 4 big ass empty capacitors through a full bridge rectifier. Now, usually in a well-designed piece of equipment, to account for this, there will be some kind of circuit that will charge these capacitors slowly, or not too slowly, but will allow for some slower charge of these capacitors so that these empty caps aren't presenting themselves directly to the mains that you've just plugged it into. Because as you know, an empty capacitor presents as a dead short circuit until it gains even the tiniest bit of charge. So when you initially present this device to your mains and plug it in, it sees 4 empty capacitors that are essentially a dead short. So the current spike from your mains is astronomical. It's massive, big current spike. And unfortunately in the UK, the breakers here are, I think they're type B, they're B curve breakers. So they will allow, I think it's 3 or 5 times the breaker's rated current draw in an impulse spike before it trips. Okay, so the breaker on the mains for the rings here are 30 amps. Okay, so plugging this into the UK mains every time tripped a 30 amp breaker. Which means that the current was spiking higher than 30 amp, like by at least 3 or 5 times. Now, in Brazil, where these are designed and tested, they have 110 volts AC, so lower voltage, and therefore higher current. So their breakers will be higher current to start with, and also I think also their breakers are B curve, which can allow up to 10, I think it's 10 times the breakers rated in an impulse spike. So in Brazil and lots of other countries where they have those kind of main setups, plugging this in, albeit will create a big current spike, it won't actually trip any breakers, and it's fine, it won't cause any issues. Aside from some nice big sparks on, and some big sparks and arcing on the terminals of your plug, which I actually saw on the plug that this came with from Brazil. The Brazilian high amperage current plug had some big spark arc markings on it because of that. So obviously that doesn't work in the UK because we can't have the breaker tripping every time you plug it in. And I said that this one failed, and this one failed because that huge current spike resulted in some kind of unintended, unthought about voltage spike on the circuit, and it blew up the MCU right here that controls the mains power supply section. So it blew up the MCU, and it also completely destroyed the display, the screen display that goes here, which I have desoldered and is somewhere up here. I can't remember where I put it. But yeah, it completely killed the display and it completely killed the MCU because of the voltage spike that occurred when it drew that immense amount of current and tripped the breaker. So what I've had to do is just fit a quick modification. I've had to fit a relay here, which the relay can, I think this is a 30 amp relay. So it's a 30 amp relay, 250 volt, and all it does is we have mains coming in, sitting on one of the open contacts here. Okay, so we have mains coming in, sitting on one of the open contacts, and then we have a couple of resistors, and I think this is 200 ohms. So the main comes in and it charges, this contact's open, so it charges the rail caps through the full bridge rectifier through 200 ohms, that there or thereabouts I think it is, which obviously is slow enough for the current not to spike and trip the breaker. It charges the caps in maybe like 2 seconds or something like that, which is slow enough to not draw excessive current from the mains. Now that's fine, that stays, the relay stays open, okay, at all times, and the only time that the relay closes, so the only time that the relay closes and allows full current to pass from the mains to the full bridge rectifier is when the unit is powered on and the relay coil receives 12 volts from the output terminals. So the output terminals are going to provide anywhere from 12 to 14 volts, 14.5 volts or whatever. So when I ask this device to turn on and I hit the power button, the 200 ohms across the power, the mains, is low enough that the whole thing comes to life perfectly fine. There's no issues. It turns on, as you've seen just now, turns on perfectly fine. And the moment that the output side here starts switching and provides 12 volts DC or more on these terminals, it energizes the relay coil and closes the relay, allowing full current to pass across the relay. And then when you turn the device off, the relay contact opens again, and then, yeah, ready for next time you plug it in to not draw excessive current. So that's the modification that I've had to make to this to make it usable here in the UK. And when I approached Taramps about this, I was like, hey, this sucks. We can't use this. And it killed this one. They did send over a new MCU and everything, but I was like, we can't use this. And interestingly, other Brazilian brands that make power supplies like this, like the Powerus 200 amp power supply, actually incorporates something very similar to this modification that I've made. It incorporates a resistor and a relay in order to slowly charge the bulk capacitors when you plug it into mains. And that works great, obviously, but Taramps decided not to do that and just give the bulk capacitors a direct connection to mains when you plug it in, and all hell breaks loose. So yeah, I think it's what is it? Yeah, so in the UK we must use B-type breakers, and I think in the Brazil they use a C-type breaker. Either way, the breaker curve in Brazil allows for a higher current spike. The new Solo X is kind of a disappointment in my opinion, especially the 18. Interesting. Why'd you say that? I haven't seen anything about it. I haven't ever had one here. I haven't watched any videos of them or anything, so I don't know any information about them. But if you have some experience or info. Yeah, what's your thoughts about it? Why is it disappointing? What have you learnt about it or seen about it? Does it take much power? Does it not take much power? What's the jam on the new Solo X? Just pop that back up on my bench up here.
No, big up for the little mod you done on that Taramps. That's hard.
No, that's cool. Yeah. So as soon as yeah. Oh, another thing that I'm waiting for. So Donnell's going to get one of those. That one probably, or the one that I've been using to use in his bench test setup. But the problem is because you use lithium, he needs something that charges high current at like 16 volts, and those Taramps power supplies, they max out at about 14.4. So there's a modification that you can do to those power supplies to get them up at 16 volts, and I could probably work out what I would need to change in order to get the voltage up, but rather than spend like potentially a couple of hours figuring that out, Taramps apparently can tell me what the modification is, so I'm just waiting for them to tell me what the modification is so I can just do it. But they're taking their sweet ass time in actually getting back to me about what the modification is, so
That's fine. I still can't believe I went through 8 power supplies.
oh yeah, that's mad.
And they gave me the big bangs, them ones. I've still got them though. Maybe I can send them up to you.
What's a repair?
No, just for parts. There's bare parts in there, bro.
There's no parts in there. You know, I think if you sent them up to me, I would probably try and repair them. Rather than stripping them for parts, I'd try and repair them.
Could do what you want with them.
Would you rate the new Kicker Solo X subs close to DDZ? No. Well, I don't know. I mean, the DDZ subs, the motors are immense. The DDZ motor is astronomically strong. It is the best motor on the market, bar none. The Z4 motor, the new one, the black one that I've got a couple of, unbelievable motor. And pair that with a good set of soft parts, and you have probably one of the best subwoofers in the world that exists. Yeah, I would doubt that the Solo X motor is anywhere near that. Don't know what the Solo X soft parts are like, haven't seen them. Would HP PD30 with a mod to charge higher would be great setup like that. I don't know what HP... Oh, the HP server power supply is. Yeah, maybe. Donnell was using kind of something very similar to a server power supply, and they just kept blowing up. The new one uses the same motor.
Turn the overload down.
Yeah, the new one uses the same motor on the 18 as the 15. So the 18 will be arguably weaker, but for its size, than the 15. The 15 will be a stronger driver than the 18, because the 15 will have more motor strength to cone area ratio than the 18 will have. So the 18 will behave like a sub with a weaker motor for its size, because it's the same size as the 15. The 15 will feel like a more powerful driver, but obviously it depends on, the cone area of the 18 is obviously going to play a part. So it just depends on how balanced they are and what you're doing with them. But yeah. I think now's a nice time to wrap up. So tomorrow I'm going to be receiving the Base Phase 5K back from Donnell. I've got my parts here already, so we're going to be doing some modifications to that. I'll probably jump on a stream tomorrow. So if you're about tomorrow at this sort of time, a bit earlier, maybe like 3 or 4 hours earlier than what time it is now, I'll start that live stream probably, and yeah, we'll do some modifications to the Base Phase 5K, get it sent back down to Donnell, and see if we can make big power without it blowing up.
Yeah, man.
But yeah, thanks for jumping on, guys. Appreciate all the donations, 13BTRX especially. Thank you very much for your very generous donations. That's really, really kind of you. Really awesome stuff. Yeah, I'll catch you guys if you're about tomorrow for some Base Phase 5K and modification shenanigans. Yeah. It's great having you. Do you want to say anything before we shoot?
Yeah, no, it's been a good stream. I can't wait for the next one.
Yeah, no, cool.
No damages this time.
Nothing
so,
blew up. Nothing blew up this time, so that's
yeah,
calm.
very
Yeah,
happy
nice
about
one. All right, guys. See you in the next one. Take safe. Bye.